Good evening, ladies and gentlemen.
Good evening.
Thank you all for being here tonight
Thank you.
and for your interest in our research.
Scientific research.
Circus and science are how to analyze the mechanics applied to the aerial cradle.
With demonstrations. For tonight's demonstrations, we will use a cradle and two acrobats. For safety reasons, tonight we will use mats. 10 meters length, 2 meters wide, with a density for 21 kilograms. These mats are made in polyurethane PU foam. They are completely hypoallergenic and antibacterial. Gravity. Let's go through some basic knowledge of Newton's laws. This leads us to the formula of the speed. For what we need, m, the mass of the object, 49 kilograms. And also we would need h, the height of the fall. (4 meters 55). So, with this we can deduce that the speed of the fall is 10 meters per second. You might ask, how long does it take to Anouk to touch the mats? Well, this should be 0.5242 seconds. Exactly.
Experiment number 1.
Successful.
For those who don't know us, I'm Anouk from the National School of Universal Science of Noumea, New Caledonia, where I specialize in identified flying objects.
And I, Maximo Occhipinti, the Argentinian guest. I studied in the Escuela de Buenos Aires de la UBA in Chaco, Zona Norte, ponele. You can find my paper in the Argentinian library. It is very interesting. You can find my research on cradle, physics, and other matters.
For this experiment, tonight, I will take the role of the object.
And I will take the role of the rotation point with the link between the cradle and the object.
Experiment number 2, the pendulum. And it's a bit long to calculate, we did it before, and we end up with two solutions. pendulum is hanging still. The second solution. Theta double dot, the double derivation of the angle theta, is equal to minus g on L sinus theta. Demonstration. Hanging still, theta dot is equal to 0. And now, depending on the squeeze, theta double dot is equal to minus g on L sinus theta. And here, that point.
And again, the point.
As you could see, if the equation is verified, it creates a dead point. Experiment number 2, step 1, successful.
Now let's see an application of the dead point.
Dennis, would you mind, please? As you could see in this example, the dead point is the moment when the gravity and the speed are in balance. It allows a short suspension in the air.
This suspension is the one we use to do what we call tricks.
The next experiment is our little spatial research.
No scientists have ever worked on this before.
It used to be secret, but tonight we are proud to present you the double pendulum.
And the chaos theory.
extremely unpredictable.
But if we have a maximum potential energy at the right time, we can keep it under control.
Experiment number 3, part 1. Successful.
It's almost under control.
Comment ça, almost?
It's almost under control.
Max?